So like Adam said, the sort of new and interesting parts about this project are, one, we're going into, while only for 3 weeks, we're going into a much finer detailed scale of looking at the vegetation and the differences in the community. And also with the herbivory, most of the herbivory has been done through dung counts. So how many animals are pooping on the landscape, and therefore putting nutrients back into the landscape. But now we're going to use camera traps, or we have been using camera traps. So we're going to use camera traps to analyze the behavior of the animals, which is a much finer scale, more detailed way to estimate herbivory. So through camera traps, we're going to analyze the images, develop some algorithms to be able to sort through the thousands of images that we have, and be able to say with greater confidence what the animals are actually doing. And is it just because the vegetation is different that they're there, or are there some other behavioral changes that are structuring this community? Right now we're putting a stake in the ground so we can put up cameras, motion-triggered cameras. Cameras will hopefully catch herbivores, either walking or eating in the glade. And that will give us some measure of how much herbivore grazing is going on. And we can then correlate that with the vegetation metrics that Adam's collecting and the insect metrics that Jacob's collecting, and be able to tell some sort of story about what shapes the communities here.
So from computational perspective, manual labor for people working with camera traps, we're going to develop some image processing and machine learning algorithms. So first we're going to try image processing algorithms, which will consist mainly of background subtraction techniques. And we'll try to see how we're going to use the property of the camera traps that mainly all of the pictures for the same camera have exactly the same background. So we're going to see how it changes and if there's some difference where the animals are. So this is the first approach. The second approach will be more as of detecting where the animals are and what kind of animals that is. So we're going to use deformable part models probably for detection, and this will allow us probably even to detect the behavior of the animals. Not with high precision though, I don't think anybody has done that before, but we could try that. So with deformable part model you could tell how animal parts are actually placed. For example, if a zebra is looking down or grazing, for example, or if it's looking up, so we could try to see if we can predict the behavior using that model.